Hi everyone. This presentation is intended for those who are not electrical engineers or even electrical engineers who don't have any background about the electrical wiring that we have it inside our houses. So this is like a very basic knowledge about the power system, but more specifically about how the power reaches to our houses and we can utilize it. So if we look to this diagram, shows the whole power system. Here we will have what we call here is the generation. This is the big towers that we see them is the transmission. And then as we come closer to our houses, this part is called the distribution system. Now in the distribution system, we can see these poles where we have high voltage lines. Now these poles has a voltage can go from 28 kilovolt, 11 kilovolt, 6.6 kilovolt. There are different standards about this voltage. And we can see these poles outside our houses, so they are very close to us. Of course, now I'm talking about people who live in North America, where overhead lines is the main carrier of power at the distribution level. Some other countries they use underground cables, so you cannot see those poles. And in some areas, let's say about downtown cities, where is a lot of people and it's very crowded. It's not safe to have overhead lines, so we use underground cables. But this is very normal in North America. Okay, so this voltage is extremely high. I cannot take it to my house. So what I have to do, I have to step it down. How to step down the voltage to a level that I can utilize. Like for example, here in North America, we have 110 volt or 220 volt. Okay, in some other places they have 220 volt or 400 volt. So we need a device called the transformer. Oh, not this, not this. This is not the transformer I'm talking about. There is another transformer that is used to step down the voltage. It is this. So we can see them here in the streets in two forms, either over a pole like this one, or on the uh, pad mounted on the ground. Okay, and we see those transformers in front of our houses. So the output of those transformers will be step down to a level that we can utilize. Now, when the power comes to our houses, the first thing it sees is the meter. Okay, so that to charge you. So those meters could be like that traditional meters, we call them electromechanical meters, or the digital ones, okay, or the smart meters. And you can check in front of your house. Most America, we have now the smart meters, and in the smart meters, the energy in kilowatt hour is measured, so that every month you are billed with how much kilowatt hour you have consumed. Now after this, after we finish from the metering, we come to the electrical panel. And in the electrical panel is the one that is responsible to receive the power from outside the house, which is coming from the transformer to the meter to your house, and then it will start to distribute this. And you can see these wires here. Each one will be connected to different circuit in your house. We have those switches that will be used for protection and control of the electrical power inside your house. We'll talk about them later on. And we have main switches, bigger switches to switch off the power from the whole house. Now, as you can see here, these wires will go inside the houses and it will reach to your sockets or outlets, to your loads through those wires. Okay, you will see that sometimes there are two breaker. We call them circuit breaker, or sometimes we call them miniature circuit breaker, MCB for short. Two of them is connected to one load, like the stove here. Okay, and sometimes only one wire is connected for the sockets or for smaller loads, and I will talk about that as well in details. These numbers 12, 14, these are the gauges or the size of the wire, and as the number reduce, the size increase. It's funny somehow, the gauge system. So a gauge with 6 is cross-sectional area is larger than a gauge of 12. So to sum up everything here, we have the power at high voltage here coming to the transformer. So this is a schematic of the transformer. We are getting the power at two different voltage levels, either 120 or 240, coming to the house. This is the electric meter. Then from the electric meter to the panel, the electric panel inside your houses. Now we have those switches, 120 or 240. If they are two together, then it is 240. And, and if it is 120, if it is a single one, and then it is 120, and it feeds these sockets. Okay, so now I'd like to invite you to my house, and we'll try to see uh, how these parts look like in reality, how the panel, how the transformer, the overhead lines, the meter, and so on and so forth. And I will explain a little bit more about these different parts of the electrical wiring in our houses.
Hi everyone, and welcome to our neighborhood. So this is the transformer that is feeding my house and some other houses in the neighborhood. So the transformer is fed from the overhead lines. It's there. This is the pole that is feeding the transformer. So the cables will go underground until it reaches this, what we call them, pad mounted transformer. The voltage will be stepped down to 120 to 40 volt, and then again it will go underground until it enters the house. Where it goes to the heart of the electrical design inside the house, which is the electrical panel. So please join me and let's have a look to the electrical panel and the switches that we just mentioned in the presentation. The entrance of the electrical wiring to a house start from what we call the electric panel. So if you look here at the bottom of the panel, we have the wires coming from outside the house, and then here it is connected to the panel. Now when it is connected to the panel, it will be distributed to smaller wires, and those smaller wires will be connected different part of the house. Now those wires, or we call them circuits, so each wire of those is connected to a different circuit in the house. They could be connected to one load, so a circuit has only one load, like for example a stove or a dishwasher, or it could have multiple loads like lighting or like sockets. So let's have a closer look here and see there are some numbering here, as you can see here, 32, 30, 28, 26. Those numbers correspond to these numbers here on the panel that shows which load is connected to what switch. So this will help you if you want to come and disconnect a certain part of the house. You come here and disconnect it, and this is actually the first purpose of those switches. For example, if you come here and look to number 9, we have the dishwasher. Now the dishwasher here is disconnected. It's in off position here. These are all on position, but this is in off position. Why? Because there is some maintenance here and we are disconnecting the dishwasher. To be safe to do that, we come here and switch it off. What is the other purpose of those switches is for protection of overcurrent. As I said, one of the loads that we have, for example here, 24, 22 is bedroom plugs. 18 and 20 also are bedroom plugs. Now, those are the sockets that we have in the house. So there are multiple of them. Okay, not just one socket, multiple of sockets connected in parallel. Now, most of the time, those sockets, they don't have anything connected to them. And the designer assumed that you will not connect those switches at the same time. But if you do so, and you connect large load at the same time, like hair dryer, like an iron, like a vacuum, all at the same time, what will happen? You will be consuming a lot of current from that specific circuit, which will lead to an overload, an overheating in the cable. To protect the cable from being overheated and leading to melting of the PVC material or the plastic material, this will trip. So the second purpose of those switches is a protection for your house from any overcurrent. Finally, we see here a big switch, and this we call it the main switch. And if you disconnect that switch, you will disconnect the power from the whole house. So this is the electrical panel, or this is the entrance of your electrical design inside your house.